So here are just some examples of the contact points chosen by the algorithm. Here's a brain. So in the previous examples, we assumed that all directions of wrench space are the same, but in the more general problem where you've got a given set of wrenches you want to resist, the solutions differ depending on how strong gravity is relative to the other disturbances. So as you see, the solution changes based on the strength of gravity. So now I'll show that with a very minor change in how we solve the problem, we can apply it to a problem in towing. So here the problem is you've got a bunch of helicopters that are attached with ropes to an object you're trying to carry, and you want to figure out where to position your helicopters based on some wrenches you want to apply to the object. And you want to, the optimization problem is you want to be able to hold up the object and also resist unexpected disturbances that occur during a movement. So let's look at one helicopter and the wrenches that it can apply to the object. So it only applies forces along the rope directions, and the total lift of the helicopter is bounded. And that means there's a convex constraint on the set of wrenches that one helicopter can apply to the object. And that's a function of the position of the helicopter. So let's look at how the complete algorithm changes in the helicopter problem versus the contact point selection problem. So actually the only thing that changes is that first part. So it used to be that we had a friction cone for each candidate contact point. Now we have a set of wrenches for each possible helicopter position. And so given that set, then we calculate a table of values that says for each disturbance, how much does each candidate contact point or helicopter position contribute to resisting that disturbance. So we compute that table of values, and then we solve the same optimization problem. So yeah, we just changed the first step. And as you can see, when we solve for the optimal helicopter positions, they depend nicely on exactly what load they're going to have to resist. So if there's a light load, but you're worried about horizontal or rotational disturbances, then they take lateral positions around the object. Whereas if there's a heavy load, then they're positioned directly above the object, because they're mostly concerned with holding it up. And if they need to pull an object in a direction, then they're positioned on that side of the object. Let me summarize. The other day, my robotic friend asked if I had some advice to lend. He asked how to hold an object tenderly, with the grasp of the highest quality. I said, let's be clear that the goodness of clenches is a residual radius in the space of wrenches. For that, there's a formula, not exact but near. It's based on discretizing the sphere. Then you can use submodularity to find good contacts rapidly. He said, thanks, John. Now I can relax my motors. I'll catch a ride home from a flock of quadrotors. Thank you.